Okay. All right. So first thing is this word neutral, right? Atoms are neutral. And we talked a little bit about this last week. It should be written on page 15 of your notebook from last week. But remember, the word neutral means no charge. Okay? And that means that for every negative charge we have in an atom, we also must have the same amount of positive charge to cancel each other out, right? So here I have 1, 2, 3, 4, 5, 6 units of negative charge. That means I have to have 6 units of positive charge, so 6 protons. All right, and we learned last week that the protons are in the nucleus, and therefore the nucleus has an overall positive charge. The electron cloud has overall negative charge. Okay, so those two things should be canceling each other out in an atom. All right. Let's also take a quick look at the periodic table. So last week I showed you a periodic table that had just this information on it. Okay, it had, and hopefully you guys, some of you may have looked at your notes already for this week, and so some of these words I'm going to use today will be familiar to you. All right, so it has the element symbol. And you don't have to write any of this stuff down yet, okay? In our notebook, we're just going to be writing down the 3 practice problems that we do in a little while. All of this stuff will wind up being on page 18 in your notes today, or this week. And then we had this number right here, which is our atomic number. And does anyone remember from last week what the atomic number tells us? What particle is the atomic number related to? You can unmute yourself or you can type it into the chat. What particle is the atomic number related to? Okay. All right. So the atomic number is really important because it's the number of protons in the nucleus, and the number of protons is what decides what element the atom is going to be, right? So all atoms of hydrogen have 1 proton. All atoms of helium have 2 protons. And notice it goes bigger and bigger because every time you add 1 proton, you change the identity of the atom. Okay, so it gets bigger by 1. Every single time you add a proton, you change what element you're looking at. All right, now we have this other number on the bottom that we haven't talked about yet. This is going to be new for this week, and you'll have this in your notes as well. Okay, so this number on the bottom right here has to do with the mass of the atom or the element, okay? So this number is a decimal value. It's a decimal value because it's an average. It's the average, atomic weight. All right, and you might be like, well, why are we averaging them out? Okay, so remember we have these things called neutrons, and neutrons also make the atom heavier or lighter depending on how many neutrons you have. Electrons don't really weigh anything, right? But if we have a heavy atom that has more neutrons, we have to average out the mass because there's also lighter atoms that have fewer neutrons, but they're still the same element as long as the number of protons didn't change, okay? And so we're going to be using this number today to help us figure out how many neutrons are in the most common atoms of certain elements today, okay? So we're really just going to be rounding these masses to whole numbers today. All right, so this is where we're going to start doing some practice. Let me bring this down a little. And we're going to be drawing something called Bohr models, because our whole goal for this week is to be able to look at any element on the periodic table and draw a picture of a model of that element, okay, of an atom of it. And so if you go to your notebook, I'm going to show you how to set this up. Okay, and can you guys let me know if this is big enough? Can you see me writing on this? I think I can zoom in a little more. Hopefully you can see the writing on this. Okay, thanks Jared, thanks Nathaniel. All right, this is an element tile over here for beryllium. It's basically, I just took that one element off of the periodic table, right? So we have the spelled out name, we have the atomic number, so number of protons, we have the element symbol, and we have the average atomic weight. All right, now we're gonna get some information off of this in your notebook. So we have 3 examples to do. So basically, we want to write this so it takes up about 1/3 of the page, right? Write the element symbol. And I'm going to see if I can focus this a little bit more. It's a little blurry. And write the atomic number of, and below it, we don't want that decimal value. We want to round this number to a whole number. Okay, so remember when you're rounding, this number right here, the 0, determines whether we round this up or leave it alone. Okay, so if the number after your whole number is a 5 or bigger, round it up. If not, leave it alone. So beryllium is going to have 9 right here. And when we round it to a whole number, now we call it the mass number. Okay, so everything I'm writing on your notebook here, you should be including in your notebook also. All right, the mass number is the number of protons plus the number of neutrons in the nucleus. Okay, and that is true for the most common atom of beryllium, right? And so that's the most common atom is a type of isotope, right? So the most common atom you're going to run into in nature, in the world, is going to have a total of 9 particles in the nucleus. All right, 4 of those particles are going to be protons, and the rest of them will be neutrons. All right, so now we're going to list all of the particles. Oh, can everybody else hear me? All right, so we're going to count all the different types of particles in beryllium just using this information. We can know how many protons, we can figure out how many neutrons, and we can figure out how many electrons. Okay, so the first, all right, so remember we said that the atomic number is the number of protons. So we're going to put a 4 right here. Okay, also we said that the atom is neutral. You have to have the same number of protons as what? What else has to be a 4 in order to make this a neutral atom? Electrons. Awesome, thank you, electrons. Okay, so right away, we can know the number of protons and number of electrons just by looking at the atomic number. Okay, now the neutrons are going to be the difference between these 2 numbers. Okay, so when you're finding the difference, the word difference means subtract, right? And so when you subtract, always put the biggest number on the top, take away the smaller number, and we get 5 neutrons. Okay, so we're finding the difference between these 2 numbers to find out how many neutrons. Okay, does anybody have any questions about how I did any of these? All right, the second part of this is we're going to take this information and we're going to draw an atom. The drawing of an atom that I'm going to make is called a Bohr model. And the Bohr model is what you saw when we did the atom activity last week. So let's see if I can grab that for you real quick. There it is. Okay, so when we did this atom activity last week, and you added the electrons in, and you saw that they had circles of electrons in the electron cloud, and all of the nuclear particles, the protons and the neutrons, were in the center. We call this kind of drawing or kind of model a Bohr model. Okay, just so you know. All right, so let me move that back. We're going to come back to that in a second. All right, so we're going to put the protons and neutrons in the nucleus. Now, atoms get really big. Okay, so some atoms have, close to 300 total protons and neutrons in the center, and we don't want to have to draw that much. So what we're going to do is we're going to label it. We're going to say that there's 4 protons and 5 neutrons. Then we're just going to give it a little bubble to represent the nucleus. Okay, that saves us a lot of headache in having to draw all those circles and then put positives in them and leave the neutrons blank. Okay, next we need to create some of those circles for the electrons. We need a total of 4 electrons. Okay, so let's see how that has to look. All right, if I add 4 electrons in, it looks like I've got 2 on the inside circle, and in fact, the inside circle, we call that the first energy level, can only hold 2. Okay, and the other 2 are on the outside. So we're going to draw that. And learning how many electrons can go in the energy levels will be part of your note-taking for this week. Okay, it's basically the last slide on your notes for this week, and so you'll have that information in your notes. All right, and so I put the first electron, and you don't have to label these, I'm just doing it so that you can see what these dots are. Those are electrons. Normally just putting the dots on there is enough. Okay, I'm going to put a couple more, and these electrons like to be spread out as far as possible because negative charges repel each other, so they spread out. All right, so here's my other 2 electrons. Now I have a total of 4 electrons. And this is my Bohr model of beryllium. Okay, so that's our first problem done. Okay, and we'll be ready for our second one. All right, for the next one, we're going to do oxygen. Okay, so that means over here we're going to write down the element symbol, and we're going to write down the atomic number and the mass number for oxygen. All right, so see if you can figure out what the mass number should be. All right, what mass number should I put down here? If I round 15.999 to a whole number. Thank you, Nathaniel. Correct. Okay, so 15.999 rounds to 16. So that tells me I have 16 total particles in the nucleus. All right, now we're going to count up how many protons, how many neutrons, and how many electrons. All right, so let me give you a second. Try it on your own. See if you can determine how many protons, how many. Oh, why did I put 4 on top? Did anybody else catch that? I wrote 4 again because beryllium was 4 when really I should have. All right, is anybody willing to share their answers? So how many protons, neutrons, and electrons did we get for oxygen? Yeah, 8 for all of them. Good work. So protons and electrons came from the atomic number, right? 8 protons, and because it's neutral, we have to cancel that out with 8 electrons. Good work, Morgan. And then for the neutrons, we had 16 minus 8, which also gave us 8 neutrons. All right, so let's take that and let's make a model of it. All right, so in the center, we're going to draw our representation of the nucleus, 8 protons and 8 neutrons. And the reason why I put it in a bubble is so that it doesn't look like it's part of, like it's an energy level. Okay, I want it to look kind of like a nucleus. All right, and then we know we need 8 electrons and only 2 electrons can fit in the first energy level. Okay, so I'm going to go ahead and I'm going to add those 2 electrons in right here. Okay, so the first energy level has a total of 2 electrons. All right, and then I'm going to go and find out, well, how many electrons can I fit into the second energy level? I want to make sure that I don't need 3 here, right? So here I've got 4 electrons. Let's go up to add in our 8. Well, it looks like all the other ones can fit into the second energy level. Okay, and you're going to find out in your notes today that you can fit up to 8 electrons in that second energy level. Okay, so I'm going to go ahead and draw this and add the remaining electrons into the second energy level. Okay, so I'm going to be drawing a total of 6 electrons here, all right? And I'm going to spread them out. All right, there we go. And so this is my Bohr model, or you could even just call it an atom drawing, but it's specifically a Bohr model of oxygen. All right, our last one for today is going to be calcium. All right, so write down the 2 numbers that go on top and bottom of the calcium symbol. All right, and once you've written down those numbers, then write down how many protons, neutrons, and electrons the most common atom of calcium has. All right, so we had 20 for our atomic number, 40.078 rounds to 40. And so this tells us that we have 20 protons. And if we have 20 protons, that means we have 20 electrons. And we also have 20 neutrons. All right. So now now you guys will really appreciate the fact that you can just label your nucleus like this, because if you had to draw 40 little circles in the middle, that would get crazy. All right, and so we know we can fit 2 of our electrons in the first energy level, and we can fit 8 electrons in the second energy level. So that will bring us to a total of 10. All right, so we can have 2 electrons here, we have up to 8 electrons here. That means that we need a third energy level, but we don't know how many electrons we can put in that yet. All right, so let's add in the ones we know. 2 there, and we're going to add in some electrons here. Okay, there's a total of 10. We have 10 left. Okay, so let's take a look at our model, our gizmo model. And the problem with the gizmo model is, okay, so there's 10. That's what we have right now. There's only 8 electrons left out here. If I put them all in, you can see that they all go into the outer one. But if I had more electrons, they would still continue to go into the outer, that third energy level. Because it turns out the third energy level can actually hold twice as many electrons as the second one. Okay, so the third energy level can hold 16 electrons. So we can just go ahead and write in all 10 of our electrons on this energy level here. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there we go. Let me that. All right, now I have my Bohr model of calcium. All right, and there's a reason why we draw these energy levels. Also, one thing that we're going to label on here, and you can use your pencil or whatever, I'm going to highlight it. Okay, this whole thing, all of these energy levels are called, they make up the electron cloud. Okay, it's just that the electron cloud is broken into these different energy levels. So the whole thing all together is the electron cloud, but this is energy level 1, energy level 2, energy level 3. And it turns out that if you're talking about huge elements, like let's say uranium. Uranium is the largest naturally occurring atom on Earth. Anything bigger than that has been man-made, all right? So a uranium atom would have like 7 of these. Oh, did I freeze for everybody? And if so, where did I freeze? Where did I stop, Alicia? Okay, so the most energy levels you can have are up to 7. Okay, there currently are no atoms more than 7 energy levels, although scientists are trying to create bigger and bigger atoms. And if they succeed, yeah, and if they succeed, then they will have created the first atom with an 8th energy level. And so that will probably happen in our lifetimes. It'll be interesting. Okay? All right, so that's it for class today. Guess what, guys? We just did your assignment for this week. Okay, so you can go to Atom Practice 2 on our Canvas page, take a picture of this, turn it in, and your assignment is done. The only other assignments you have for this week are to take your notes and to take your quiz on Friday. All right, when we meet again on Friday, we're going to play a review Kahoot before you take the quiz.